Okay, here is our recomposition graph, and what you can see is lots of different colors. So we will just start by looking at the black line here. So the black line is the same graph as in your first graph that you made, and it's just your raw data plotted against time. So we can see what's happening as our long-term trend. This blue line, this is our smoothed out data. So imagine taking this data and kind of squishing it together, and rather than having all of your peaks and troughs, you've just got one smooth line. And that's what we call our trend. So you would have heard me talk about the trend in the seasonal effects video, and this is the line that I'm referring to, this blue line here, our smoothed out data, what is happening over time. The green line is taking this trend, this blue line, and it's adding the seasonal effect. So in quarter one of 2000, it took the trend and it added the seasonal effect for quarter one. And for quarter two, it took the trend and once again, it added the seasonal effect for quarter two, and so on. And it's done this throughout the whole graph. And that produces the green line. So that's the trend plus the seasonal effect. And you can see the seasonal effect is plotted down here. The residual is the difference between the black line and the green line. And if we had a perfect model, our green line and our black line would be laying on top of each other. We can see that generally they are very, very, very close together. Here is where it starts to get a bit different, here and here. So our residual, if it was perfect, our residual would be along zero. We obviously it's a model that's never going to happen. So we're looking for the residual to just fluctuate just above and below. Here it gets quite a big difference. This is quite a fluctuation. So we can say that this model is great for this period of time. However, a different model might be better suited for this section.